Hello, welcome to another Teacher Tobin tutorial. We're going to be looking at utility software, part of topic 3, which is a 3.2.2 specification for the curriculum map. Edexcel GCSE Computer Science course for exam preparation. It's going to be quite a short video. Some of the other videos in topic 3 have been pretty long and extensive, and even the operating systems one prior to this is also quite long. Just to build quickly on that last video, I talked about peripherals and drivers and device management. I forgot to mention that buffers are used to compensate for the difference between the CPU and a device. So you might have a printer which is measurably slower than the CPU. So to act as a conduit in between there'll be a buffer. So just to add that to that last video. So this would have been on the video about operating systems. So that's just a little side note there. So let's look at utility software, and we're going to go through some exam style questions as always. And there are lots of different utility softwares available on the computer. Some of the easiest to remember might be anti-malware software. So malware, the clue is in the name. Mal, as in it's got a negative connotation. Malpractice, for example. It's software, and malicious software is what it stands for, by the way. Malicious software. Its sole intent is to cause nuisance and harm to programs or data. And anti-malware utility software will find patterns of known code. They'll find patterns of known code. It might be shapes of source codes or certain things that they use, and then it will quarantine those. So the software companies have this big database which they continually update with virus, what we call signatures. And we'll talk more about the differences between viruses, worms, trojans, malware in another video for topic 4. So this isn't going to be a deep dive right now, but in general, these companies, they'll offer multiple products in the same utility software. So they'll be looking for worms which propagate themselves without the user knowing, all types of malicious software. And if they've identified one from the community, or people have said, "Oh, there's something going wrong, let's have a look at it," they'll put a signature up onto their database so that any users of that anti-malware software can access the signature to check whether they've got something similar on their own computer. So that's a very important utility software. There's also there's lots of others, like file repair software utilities. So data can become corrupted, especially if a disk develops a fault. Maybe a little sector on a disk has just corrupted and it's not going to write to that sector properly. So repair software can sometimes help repair files. And repairing files can, from so especially mechanical hard drives, can be quite a skilled endeavour when you're sort of physically looking through the platters and trying to recover as much info. What's important to note is, let's say you've got a USB stick. And it just suddenly stops working. The USB stick stops working, and you're not being able to read and write to it. The more you try to use that stick, the more likely it might not be able to be recovered from, because all the files are still on there, and all the data is still on there. What usually happens is when you delete a file from a hard drive USB stick, is it just says that those blocks are available to be overwritten to when you need. So if you delete something from a USB stick, it will just say, okay, when the next file lot comes along that you need, you can pop it into that space. It's like available. So the information's still on there. It's still on there, but you might need to have special file recovery software to be able to access it, because usually the master boot record or something like that has come corrupted. This is not part of the GCSE, but it's just general knowledge. Something on Windows, you might have the master boot sector or the beginning of the disk, which tells the computer what it is. Maybe that's gone missing or corrupted or something like that, and you might have to rebuild it. So a lot of the times you can recover your data, but if there's physical damage, it can be impossible to recover data. What else can we have? We've got data compression. Data compression software. For example, WinZip, WinRAR. So they allow you to, what's important, the term here is lossless. So if you use zip compression, you can save space. You can it's good for storing and archiving, and also grouping lots of files together for ease of archive or sending across to somebody else. The important thing is you can always unzip it and it will go back to its original form. So nothing is lost in that process. There is a lossless system. However, other data compression, for example, I don't know, you might have MP4 or MP3 or other lossy formats. Lossy means we will lose information from there. MP3s are a nice example because we all use them all the time. Your original file might be a WAV file, which is uncompressed, and then the MP3 might remove a lot of the frequencies we probably won't perceive or listen to or listen out for that much, and remove other data. Sometimes the bit depth might be reduced. So it gets rid of information that will never come back. You can never get that back. But data compression is an important part of utility software, because often we don't need to keep the original raw files of something, or because they just take up so much room. And if we've got a holiday snap, a JPEG is fine. We don't really need to have a lossless format for that. So I would say that's covering most of the main ones. The biggest one that we need to cover, and we're going to take some time to go over it, is defragmentation software. This is going to take we're going to take some time to go over this one. Just before we go look at some exam style questions, it should be noted that defrag software is only applicable for HDDs, magnetic secondary storage devices. So old hard disk with platters on them that spin around, not for SSDs. So you're not going to be defragging on an SSD. Why? Because it has no moving parts and all the data is stored electronically, so read and write is not going to be affected as much. And SSDs use things like trim, which is a different way of, and that's not in Edexcel, by the way. That's just a little bit of context and general knowledge. So when computers solely had mechanical hard drives to store everything, operating system, the file, documents, everything else, defragging software would be quite important. So you might have a local disk, and let's say it's a magnetic storage device, and NTFS is not part of the GCSE, but that's the Windows formatting system. If you put that onto a Mac, you'd only be able to read that drive. You wouldn't be able to write to it. So disks are formatted in a special way, depending on the operating system. Macs might use Mac OS Journaled, Your USB stick probably will be using exFAT or FAT32. There are limitations to the size of those. Again, this is just contextual. It's not going to be asked about the GCSE, so don't worry about that. What will be asked, and it's very likely it'll come up, is defragging utility software. So you can see here, we've got this hard drive, and this is a real hard drive, and we've got all these blank sectors here, which ideally all the blank spaces would be put together. We would put them all together, a bit like this block here, where they're all put together. So let's just talk about a misconception of defragging software. It doesn't free up space on the hard drive. It might group free space together, put it all in one place, and it will, so it will go through sequentially and look for blank spaces, and eventually it'll put all those blank spaces together. But it doesn't free up space per se. And you've got these little chunks of files. I mean, you've got this block here, and you've got this block here. And let's say, for argument's sake, that this is file 1. Let's say file 1A. It's a bit of a photo. And then we started using some other software, and we saved a file there. We can call that file 2. But then we went back to Photoshop, and we went back to file 1, and we did something else on it. But because we've already used this space, the second chunk of file 1 couldn't be saved adjacent to the original one. It's a bit like having a workbook or a journal at school, and your teacher's asked to put the date, and then you put all your notes for the day in there, and that's great. And then you go to the next class and you put your notes in, but then you realise that you're missing some notes from the first class. Where do you put them? Because you've already used this page, haven't you? So the only way is to put your notes from day 1 onto the next subsequent page, because it's a physical thing, isn't it? So that analogy is similar to what happens in a disk. So we've got 2 chunks, and let's just say, for argument's sake, that this is the rest of our file as well. This is file 1, and this is part C. Maybe this is the main part of the file. But they're all meant to be together. They're all meant to join together. And they're all there. All the bits of the file are there. But if to get to it, that hard drive needs to... The actuator arm on here needs to go backwards and forwards quite a lot to read the different parts of that file, which affects read and write speed and slows things down. So what defragging software will do is take all of those red bits and put them together. So the best way, I think, to understand how this works is to look at exam question. Let's start with an easy one first. Identify the purpose of defragmentation software. So the best answer here is C. I mean, we can immediately discount B, because it's definitely not encrypting the information at all. We're not making it difficult to read, and we're not protecting the data as well. That's not something we're doing. So it's between compressing the data or organizing the data. And compressing the data implies that we might, either using a lossless or a lossy form, squeeze our data into a smaller package. And we don't free up any space, or we're not compressing our data in this sense. What we are doing is organizing our data. So the best answer is C. So it's possible that A would trip you up, but it's not a compression software. Now, compression software might read across and see how many blocks are the same. Unfortunately, this is not in the 2020 specification, but run length encoding might say, okay, well, there are 3 times red blocks. Okay. And if let's say, for a bitmap image, and then it would have a look here and see how many of these blocks are there together. So very quickly you could start abbreviating and simplifying where chunks of similar data are. That example would be for like a bitmap image where we've got pixels the same color. But we're not compressing the data, we're organizing it. Okay, so let's have a look here. Here is an image of a secondary storage, of secondary storage. So immediately we need to know that secondary storage is, and it should really say magnetic hard disk. Okay, so in fairness to it, it does say it here. So let's carry on. The 3 files A, B, and C are stored on it. Each file is made up of several blocks. Fine. So we've got A, 1, 2, 3, and 4. That's got 4 blocks. That makes up one total file. Let's just say it's a photo. And then we've got B, 1, 2, and C, 1, 2, and 3. So complete the image to show the state after running a defragmentation utility. The important thing here will be to have all the blank spaces together. And it won't, for this question to get your 2 marks, it won't matter that if A, B, or C are sequential. What would matter is if you have let's have a look, and then B1, B2, and then A1, A2, A3, A4. So it doesn't matter if you've got B, A, and C, or as long as you've put the files together, as long as these are together, and the blank space is all in one place. And I guess you could also get the mark if you had the blank space at the beginning as well. Doesn't really matter. But that's what the defragmentation utility would be doing. It would consolidate all the file chunks, the blocks, which they call it, and put the blank spaces into one place. So you're not freeing up space. You're just making it easier for the disk to be written to, so the actuator arm that's doing all the work doesn't have to travel as far. A given reason the performance of a solid state drive is not affected. So as we mentioned before, no moving parts, to an SSD. And data, you could also say data read electronically, scattered data is not affected because it's all read electronically. Those would be the best potential answers there. And you could actually damage the SSD by doing that, because SSDs have a finite amount of times they can be read and written to before they fail. So the more that you're jostling around all these little chunks and blocks on there, the more work you're putting onto the disk and the more potential it has to fail. So you will not be defragging on an SSD ever. Good. Okay, so I think this will cover any kind of question you'll get about defragging and general utility software. If it helped, let me know. If you want more, let me know in the comments, and I'll see you in the next video.